If you want to ask questions, please speak up. Speak louder so that the camera can record your questions. Thank you.
你问这么浅显的问题，你想干什么？你想就是说，你这东西不 work， 你为什么不 work？
我还能问什么？没人问问题，我不问问题吗？
You can actually plug both of them in. Okay. Just plug both of them in.
Hi guys, we're Team 2 and our project is the Marvelous Maze. I'm Joseph McDonald.
I'm Jason Joandy.
Nils Kaufman.
I'm Nicholas Trevino. And so the Marvelous Maze, we were trying to find something that was fun, interactive, we could do again, because there's something kind of not as enjoyable about a toy you're not involved with. So we came up with something that you're overly involved with. We wanted to add as many different components to make it as challenging as possible. So in doing that, we started with an initial concept of coming up with tracks and moving components, trapdoors, things like that that would make you lose. So it was like a video game brought to life. And so the way this plays, it's kind of like every one of these individual components is like a little mini game in itself. So you have, especially coming towards this end over here, we took ideas from other games such as actual wood labyrinths, foosball, and little spring-loaded launches. So
Alright, so how we got the ball rolling. So after looking at everything that Nick just mentioned, we came up with the Marvelous Maze, and that's pretty much, with the whole competition and challenge side, we kind of came up with, kind of lose your marbles, you kind of almost go crazy because sometimes it's very difficult, just depending on, how fast you can move as well as you can compete with your friends. We also encourage you to become a master of the maze because a lot of it is skill and timing. So you can get better as you go and possibly get through the maze with either more marbles or in a faster time.
Right, so for our design, we thought of innovative combinations. So like Nick mentioned, we had a lot of trap doors and mechanisms moving, so such as the foosball, the wood labyrinth, and our spring-loaded systems. And the whole maze is made such that it can go infinite. We have infinite fun. So we were able to fabricate a conveyor belt, which can bring the balls throughout the maze over and over again. And from then on, it's up to you and your skill to be able to get the balls rolling down as fast as you can.
Yeah, so we also have a CAD model, of course, and the question is where do you start modeling such stuff? Because we of course had discussed like what features we wanted in the CAD, like in our product, but we didn't have any dimensions when we discussed it. So I had the pleasure of going ham in the CAD model, and the final product ended up being more than 108 unique components, more than like 200 in total. You should have seen the constraints. That list was huge. But in the end, the CAD model not only contains the ideal version of the toy, but also has all the fits added into it, so like tolerances, that kind of stuff. However, and we're also going to talk a little bit more about that in the end, something that we forgot to do was add in the tolerance for the paint and take that into account. But yeah, so all in all, about like 3 hours of work. So the first two features or traps, however you want to call it, are the shortcut, which is located over here, where you can push it up and down. Like, sorry, you can push it, pull it up. So per default, lets the marble through, but yeah, if you pull it up, you can actually skip a part of the track, so a part of the other traps. But the problem here is that the balls keep coming, so you have to catch it really early in order to actually skip a part of the track. So you have to keep your eyes not only on the rest of the map in order to make the marbles go through, but also the first part. And then the second one is Maverick Maze, Maverick Wave, sorry, where the pins per default are up, and you have to push it down one at a time in order to make the marble go through the wave.
And so we came up to this next part here. So if you were able to make it through the Maverick Wave, you come onto this. The idea here is the ball rolls through here, you launch it up, and this requires extremely precise timing. I think out of all of the test runs of it, I was able to get it once. So come from there, loops around to the NASA launch. A spring-loaded mechanism, pull it down, and pull it down, fires it up, launches it through the helix into the next components. These provide interesting challenges with timing because if you don't make it, it will immediately fail you and you lose that ball.
So another key feature we have is kind of the tightrope. So this is kind of based off a wood labyrinth where the objective is trying to avoid the holes, as well as the awkward stairs, which I'll get back to in a bit. So kind of the mechanism behind the tightrope is that you essentially are able to move it up and down, and the tightrope itself is slightly on a slant. So when the ball stops here, you can then roll it to the side, and the objective is to try to avoid the holes so you don't fall and lose the game. As for the awkward stairs, so that comes after the tightrope, where the marble will roll in and you have to rotate, I guess, this half gear, which will change the course of these quarter gears, which in turn change these tracks. So when the ball rolls in, if you don't rotate the track down, it will fall off and you will lose the game. So you have to roll it one way and then roll it the other and then roll it back. So this kind of requires some timing to get it right, because if you don't lower it or raise it at the right time, you could launch the ball somewhere else or have it roll off into oblivion and you would lose the game.
All right, our last two features are the foosball and our small, intricate part. So we have the Hill Purdue and RNGesus. So first part, the foosball, basically the ball goes down this track. It goes down here, and then if you did not rotate the foosball in time, the ball will just roll off and that's game over. And if you do hit the ball with the foosball, it'll go down to RNGesus, reference to RNG for random number generator, where the ball will go through some obstructions, keeping it from going in a straight line. And theoretically, there's a 12.5% chance that no matter how hard you did all of those features before, the ball will just roll off and you will just lose the game. And yeah, that's it. So initially, with our constraints of 10 by 10 inch cube, we thought if we could maximize the size, we could maximize the fun. So that's where we started. So we started with the 10, with the cube in the beginning, and we went through with our design, making a maze throughout it.
Yeah, and I already talked about the CAD model. That obviously was based on that. So we knew that the overall dimension had to be within 10 by 10 by 10 inches. So the entire box is made around 8 inches, so that we had some some space for the knob and everything.
And then we come to the final product, an amalgam of over 200 components, 260 hours of 3D printing, and several hours in a laser cutting lab to get the Marvelous Maze, the epitome of our project.
So now we will kind of do a quick little demo. We'll see how long we can, I guess, survive, if you will. So yeah, that'll be kind of hard to see, but just use the crane.
I'll just use the crane? All right. So you feed the ball into here. Awesome for that idea.
We talked about the paint.
Yeah.
So while Nicholas quickly does that, some other things that we didn't think about beforehand, except other than the paint, was, for instance, the acrylic. So the fumes from super glue really mess up with the
Might have retread.
Yeah.
You could take that from wall.
Can we? No, we cannot. Alright, well. So each one of the individual components works rather well. As combined, they do not. And then this one is a weak one. There you have it.
Yes, thank you. So my question is, when you lose and the ball falls into the abyss that is the rest of the cube,
Yep.
how do you get the ball out?
So, you want to do it?
yeah, so the entire bottom part of this this cube is slanted. So we want the ball to end up in this corner right here. You can see there's like a gathering, what do we call it? Like a reservoir for marbles. So the entire bottom part here is made as a square, and then like drew a curve here. Rotate the entire thing so you have a curved surface. So no matter where it is in the track, it always rolls down to that corner. And then we also have a box with the electronic components that is also slanted, so that if the ball lands there, which it will, yeah, it will if we have made all the other stuff work. It will also roll down to this corner over here and then follow the curve.
Thank you.
Good question.
Any questions? Yes.
Have you ever been able to successfully complete the course?
I have not.
As we said, it's very difficult.
We
Yeah.
lost on RNGesus. So that wasn't really up to us. It was in Jesus' hands.
Yeah, several of the components, like me and Jojo were playing this one for a good 5-10 minutes. We were making sure it worked, and I think we've made it through how many times?
Oh, through the tightrope?
Yeah.
Like twice.
Yeah. And using these parts here, we made it through. These weren't that bad. This one, I already said, the little ramp here, I've made it through once, so it's definitely not an easy challenge. Any other questions?
What are these like clamp looking like things on the side here?
So this is a box for the motor.
Oh, I see.
That way we could have access to everything because the on switch for it is in here.
It's like in the back.
So unfortunately the motor has kind of stopped working this morning, so.
We touched the ends of our battery together when we were moving it, and it fried it. So.
Any other questions?
What was the deal with the springs that they have, like, or with the holes, or?
Okay, so it depended on
these top three and this one, or
Yeah, like basically, but they are going through or not reacting to the thing that's going. So what's the problem with the springs?
what is the problem with the springs?
Yeah.
So,
Because they are not coming back. No, is it like just the paint or?
so some of them were a little bit of, we didn't quite have the right springs for it, so it was kind of hard to find the ideal spring for the mechanism we were doing. So I got a box of about 20 different springs, and we got the ones that were the closest, but some of them aren't quite, like if they fit, they're not quite long enough to get it all the way back up. And ones like this didn't quite fit the diameter of the rod itself, or the ones on this one is not nearly high enough, so, yes.
Do you guys have any ideas on how we can reduce the overall mechanical load now since you have the project?
like everything ran really smooth before painting, because as I said before in the presentation, we had ambient tolerances, and also the friction between 3D printed components are really low. So I would start there definitely, and then of course the springs, as we just said, like we didn't have to. Yeah, we could definitely tune those, like actually get the right springs for the right job. But like the principle is there, like where we want the springs to be placed, just about the right force and stuff like that. If that answers your question.
Anything else? All right, well, thank you for your time.